Hi, my name is Dina Madiha 305671. Will present Introduction to Mathematical Economics, assignment number A and B1. So let's look at the first question, which is number A. The question asks us to find the intervals where the function above is increasing and the intervals where it's decreasing. So the first step, we need to find the derivative of function x equal to 2x squared plus 3x squared minus 36 plus 4, and we got the derivative of function x equal to 6x squared plus 6x minus 36 after differentiation. Step number 2, factor the function of x. So the function of x equal to 6 in bracket x squared plus x minus 6. Use the calculator to get the answer, and the answer is x1 equal to -3 and x2 equal to 2. Then we got the function of x equal to 6 in bracket x minus 2 in another bracket x plus 3. Step number 3, find the critical point. So to find the critical point, as we all know, as the answer above, the critical point is x equal to -3 and x equal to 2. After that, we have to test the critical points. So the first critical point is -infinity and -3. Second is -2 and 2, and the third is 2 and infinity. For the first critical point, we have to choose another number which is less than -3. So if we choose -5, so derivative function of x equal to 6, and so in bracket -5 minus 2 and another bracket -5 plus 3. So we got the answer is 84. 84 is less than 0. So the conclusion, if the value is positive, the answer will be increasing. For the second critical point, we have to choose another number other than -3 to 2. So if we choose 1, then do the same calculation as at the critical number 1, and we got -24. -24 is less than 0. If the value is negative, then the function will decrease. For the last critical point, we have to choose another number greater than number 3. If we choose 4, then do the same calculation as number 1 and number 2, and we got the answer, which is 84. 0 is less than 84, so the function will increasing. The conclusion for this question is the function of x is increasing on -x, -3, and 2 infinity, and the function of x is decreasing on -3 to. We proceed to the next question, which is B1. The question told us to find the marginal profit MP function. To get PIQ, RQ minus CQ, but RQ is not given, so we have to find RQ first. The formula for RQ is P multiply Q. The answer for RQ is RQ equal to 200 minus 0.89Q multiply Q. So RQ equal to 20Q minus 0.89Q squared. After that, we can find the PIQ using the formula above. So we got 189Q minus Q squared minus 80,000. Lastly, we get our answer, which is 189 minus 2Q after the differentiation. The final answer for this question is MP equal to 189 minus 2Q.
Assalamualaikum, my name is Nur Fitra Fikrina binti Muhammad Rafi, my metric number 3068885. Okay, so question number B, to find the interval when the marginal profit is falling and rising. Marginal profit MPQ is derived from the profit function, and its behavior can be determined using calculus. MPQ equal to 198 minus 2Q. This represented the marginal profit as a function of quantity Q. Derivative help us understand the rate of change MPQ. If a derivative is positive, MPQ is rising. If negative, it is falling. So the formula d over dq MPQ equal to d over BEEQK1013 minus 2Q. This is derivative of MPQ with respect to Q. The result is negative 2. The derivative of MPQ is constant at negative 2, meaning that it is negative for all Q of Q greater than 0. A negative derivative implies that MPQ decrease linearly as Q increase. For all Q greater than 0, since D over DQ, MPQ equal to negative 2 is less than 0. Because the derivative D over DQ, MPQ is always negative. There is no interval where MPQ increase.
So the next question is we need to determine the average profit function. So AP is equal to pi Q divided by Q, where pi Q is equal to negative Q plus 198Q minus 8000. So we get the answer is equal to negative Q plus 198 minus 8000 per Q. So the next question is question C. A manufacturer found that the total cost of producing X units of product is given by Cx equal to 0.02x square plus 2x plus 8000. So at what level of production will average cost be a minimum? So the first step is we need to determine the AC function where Cx divided by x. So we got the average cost is equal to 0.02x square plus 2x plus 8000 per x. So the next step is we need to find the minimum average cost function where dAc divided by dx, and we got the answer is 0.02 minus 8000 per x square. So the next step is we need to find the critical point by set the derivative by equal to 0, where 0.02 minus 8000 per x square equal to 0. And so for the x, we got the 632.46. So the last step is we need to verify if it's minimum or not by using d square AC divided by dx. And we got 16,000 per x cube, since 16,000 per x cube is more than 0 for x more than 0, and second derivative is positive, indicate average cost has a minimum at 632.46 unit. That's all.
Okay, question D. What price elasticity of demand measure the responsiveness of quantity demanded to a change in price? So the formula is ED equal to DQ over DP times P over Q. dQ over dP is the derivative of Q with respect to P, while P is price at Q equal to 10, and then Q is quantity demanded. Okay, the first step is we have to find P. We have to substitute Q equal to 10 into demand equation. So Q equal to 16 minus 2P power of 0.5. So when substitute it's 10 equal to 16 minus 2P power of 0.5. So the P is 625. Okay, step 2, we have to find dQ over dP. We have to differentiate Q equal to 60 minus 2P power of 0.5. So dQ over dP is equal to d over dQ times 60 minus with d over dQ times 2P power 0.5. So if we want to differentiate 0.5, we have to minus with 1. And then the answer will be negative P power negative 0.5. So we have already find P equal to 625. And then dQ over dP is equal to negative 625 power of negative 0.5. And the final answer is negative 1 over 25. Last step is to calculate ED. Substitute into the elasticity formula. ED equal to dQ over dP times P over Q. So dQ over dP is negative 1 over 25. P is 625 and then Q is 10. So the final answer will be negative 2.5. So the negative sign indicates that demand decrease as price decrease. The absolute value ED equal to 2.5 is greater than 1. So demand is elastic at this point. When the quantity is Q equal to 10, the price elasticity of demand is negative 2.5, meaning that a 1% change in price result in a 2.5% change in quantity demanded.